Okay, so we're going to redo example 1 on the second page of lesson notes 5.1. We're being asked to find secant and cosecant of theta, given tangent of theta equal to 3. So we're going to go ahead and write tangent theta equals 3. And we're going to find an identity that links tangent to secant. So we know that 1 plus tangent squared theta equals secant squared theta. 1 plus tangent given a value of 3, therefore tangent squared is 9, equals secant squared of theta. 10 equals secant squared of theta, and therefore secant of theta equals square root of 10. We're only going to look at the positive root because cosine is defined as a positive ratio, and that exists in quadrant 1 and 4, and therefore we need to look for secant being a positive value only. Okay, now that we've found secant, we're going to go ahead and find cosecant of theta. We do know that cosecant is linked to cotan using the identity 1 plus cotan squared of theta equals cosecant squared of theta. We don't have cotangent, but we do have tan, so we can go ahead and say, well, cotan of theta is therefore the reciprocal of tan, which is 1 over 3. 1 plus 1 over 9, because 1/3 squared is 1 over 9, equals cosecant squared of theta. 1 and 1/9 is 10 over 9. And therefore cosecant of theta is equal to the square root of the left, which would give us radical 10 over 3. Also positive because we're sticking to the right half of the circle, or cosecant is positive, specifically in quadrant 1 since tangent is positive, and that exists in quadrant 1 as well. Moving forward to letter B, we are given that sine of theta minus pi over 2 is equal to 0.73. We're being asked to find cosine of negative theta. I'm going to go ahead and look at this part right here first. I see the idea of complementary in a way, but it needs to be manipulated a bit. So we're going to start with sine of, and I'm going to rewrite this as negative pi over 2 plus theta by swapping the two terms, and that's still equal to 0.73. Next thing, I'm going to go ahead and extract that negative, factor out the negative, because I want to see my complementary or co-function identity as pi over 2 minus theta equals 0.73. And then knowing that sine is an odd function, I'm going to go ahead and take out the negative and place it outside of the function, because negative f of x is equal to f of negative x. So negative sine of pi over 2 minus theta equals 0.73. At this point, I can then convert this sine of a complement to a cosine of the angle itself. This negative will remain unaffected. Cosine of theta, because sine of an angle is the cosine of its complement, 0.73. And then I'm going to go ahead and solve for cosine of theta by dividing both sides by -1. Last step, I'm being asked to evaluate cosine of negative theta right here. So I'm going to go ahead and say, well, since cosine is an even function, then I can say cosine theta is the same thing as cosine of negative theta, and therefore the value will remain as -0.73. Moving on to example 2, letter A. Now we're going to use the identity to simplify given expressions. I automatically see that this numerator is dealing with the Pythagorean identity, which says sine squared plus cosine squared equals 1. We did learn, again, I'll rewrite this for reference. So if I want to go ahead and see this as 1 minus sine squared, that means I'm really rewriting this in terms of cosine squared or for cosine squared. 1 minus sine squared of theta. Hopefully you can see that this is exactly what the numerator is up here. So I'm going to replace the numerator with the expression cosine squared theta. And then the denominator remains as cosine of theta. Well, cosine squared divided by cosine is simply cosine of theta. Moving on to letter B, we have cotan of x plus cosecant of x divided by cosecant of x. So as you can see, there is a lot of similarity in the numerator and the denominator. So what I'm going to try to attempt to do first is go ahead and split up this fraction into 2. So I'm going to rewrite it as cotangent of x divided by cosecant of x plus cosecant of x divided by cosecant of x. And then simplify each fraction separately. Cotan can be rewritten as cosine of x divided by sine of x all over cosecant, which really is the reciprocal of sine, plus cosecant divided by cosecant is just simply a 1. Then dividing by a fraction over on the left is the same thing as multiplying by the reciprocal. The way I like to multiply this is I multiply the outer values and divide by the inner values, the product of the inner values. So it really turns out to be cosine x sine x divided by sine of x plus the 1. Then go ahead and simplify a little bit. Sine cancels out with sine, and all we have left is cosine of x plus 1. And this would be the simplified answer. Letter C, I'm looking at 2 fractions being added with different denominators. So first guess here is to go ahead and create a common denominator so I can actually add these 2 fractions and see where it takes me. So common denominator would be the product of these 2 denominators. So I'm going to go ahead and multiply the first fraction by 1 plus sine of x divided by 1 plus sine of x. So we're going to have 1 plus sine of x over 1 minus sine of x divided by, or multiplied by 1 plus sine of x. And then I'm going to do the same thing to the second fraction. It's going to be 1. That should not have happened. Minus sine of x divided by also the product of 1 minus sine of x times 1 plus sine of x. Now that they have common denominators, we can combine them. So I have 1 plus 1 is 2. Sine of x minus sine of x is 0, so that's gone. Common denominator would be the product of these 2 terms, or these 2 factors, I should say, and that's the product of a sum and a difference. So we have 1 minus sine squared of x. Using the Pythagorean identity we looked at earlier, I can say, well, 1 minus sine of x is really the same thing as cosine squared of x. Okay, this is the Pythagorean identity. And then I can go ahead and simplify this fraction a little bit earlier. Since cosine is the reciprocal of secant, I can rewrite this as 2 secant squared of theta, or I should say x. And this would be the final answer. Letter D, secant of negative x times sine of the complement of x. So I know secant is even, because it's the reciprocal of cosine. So I can get rid of that negative, because we don't want to deal with a negative probably. And then I know sine is really a complement to cosine. Okay, so we're going to rewrite sine of the complement as cosine of x itself. Now secant is 1 over cosine times cosine of x. And hopefully you can see this simplifies very nicely. The cosines cancel each other out, and you'll get a final answer of it. This next problem, letter E, is a little more challenging. But if you do hit a dead end and you're not really sure what it is that you want to take as an approach, you can always convert everything to sine and cosine and try that out, see if it works. So for this problem, I see 1 plus tangent of x divided by 1 plus cotan of x. And I do know tan and cotan are reciprocals of each other. So I'm going to go ahead and write this as 1 plus sine x over cosine x divided by 1 plus cosine x over sine of x. And please do attempt different methods if you're inclined to do so, because you might actually end up with something that might be simpler and more direct and to the point. Okay, now looking at this expression right here, I see the top has a cosine in the denominator, and the denominator also has a sine, its own denominator. So in order to go ahead and simplify both of these things, I'm going to multiply the top and the bottom, the entire numerator and the denominator, by the product of these two denominators, which is cosine of x times sine of x. Let's see where that takes us. 1 plus sine x over cosine x. This whole quantity is going to be multiplied by sine x cosine x. And then the denominator is going to be 1 plus cosine x divided by sine x, and also multiplied by sine x cosine x. Okay. And we're going to go ahead and do distributive property. So the numerator is going to be sine x cosine x plus, if I multiply this quantity right here by this fraction, what's going to happen is the cosine is going to cancel out, and you're only going to have sine squared in the numerator. So we're going to have sine squared of x. In the denominator, something similar will happen. So you're going to have sine x cosine x plus, again, what's going to happen is if you multiply these two, the sine is going to cancel, and you're going to have cosine squared of x. Okay, we're going to need to simplify this a little bit further. In the numerator, you have two terms. They each contain sine of x. So I'm going to go ahead and factor sine of x out. And you're going to have cosine x plus sine x. And in the denominator, I can factor out a cosine x. And it's going to be sine of x plus cosine of x. Okay. Now hopefully, okay, we can see where this is going. So these two terms are exactly the same value, so we can cancel them out, or those two factors, I should say, and then all that's left over is sine of x divided by cosine of x, which is equal to tangent of x. And that's your final answer. All right, moving on to letter F. Again, we're going to follow the same method as before. So you see a bunch of secants and cosecants, so go ahead and convert everything to sines and cosines. So I don't see any trig identity involved. We can rewrite secant squared as 1 over cosine squared of x times cosecant is simply 1 over sine of x divided by secant squared is 1 over cosine squared of x again. And then cosecant is 1 over sine, and of course it's being squared as well. Okay, just like we did before, we see different denominators in both the top part of the fraction and the bottom part of the fraction. So I'm going to go ahead and multiply everything through by cosine squared times sine squared. So what we're going to do again is cosine squared x sine squared of x. And we're going to multiply the denominator as well by cosine squared of x sine squared of x. And I'm going to rewrite the previous fraction over here. 1 over cosine squared of x times 1 over sine of x divided by 1 over cosine squared of x plus 1 over sine of x, sine squared of x. Okay, now we distribute and clean up. So if we multiply this top by that one right here, we're going to cancel out the cosine squared, we're going to cancel out the sine in the denominator, and we're just going to end up with 1 sine in the numerator. The denominator, same thing. We're going to multiply each one of these two terms by cosine squared, sine squared. So the first fraction will turn into sine squared of theta. And the second fraction needs to be multiplied by the same exact quantity. So it's going to turn into cosine squared of, I keep saying theta, I think it should be x. All right, sine of x in the numerator. Hopefully you recognize this is an identity. Sine squared plus cosine squared is equal to 1. That's the Pythagorean identity. And then anything divided by 1 is itself sine of x. And this would be your final simplified answer. Okay, solving equations is simpler than proving identities. So we're finding all solutions between 0 and 2 pi. So we look at this first equation. I'm going to bring all terms to one side of the equation. Dealing with an expression and setting it equal to 0 is probably a lot easier. Okay, you can notice that there is a common sign factor in both terms. So pull out that sign, and you're going to have tangent squared of x minus 1 equals 0. Okay, we're going to set each factor equal to 0. Tan squared of x minus 1 equals 0. And sine of x is equal to 0 when the angle is 0 and pi, or 180. For the second factor, tangent square root of x equals 1. Therefore, tangent of x is equal to the positive and the negative root of 1. And tangent is positive and negative 1 in 4 different places at all the 45 degrees. So it's a pi over 4, 3 pi over 4, in the middle of each one of the quadrants, 5 pi over 4, and finally 7 pi over 4. So our solutions are actually a set of 6 solutions. We've got 0 and pi. And then we've got pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So I accidentally did the work for letter B without hitting the record button. But as you can see, I used substitution, looking at this as a quadratic function, and then subbed in w for sine of x, solved the quadratic by factoring, and I got w equals -1/2 and w equals -1. W stood in for sine of x, so I went back and did the substitution. Sine of x equals -1/2 and sine of x equals -1. Solved each one for x, and we got 3 different solutions, and those are the angles that would make the original equation true.